Welcome to another video on integrals, and we're still solving integrals from the MIT Integration B 2025 qualifying paper. And we're solving this integral today. It is the third from the list, and we have a cube root of 3 sine of x minus sine of 3x. So the first thing we want to do is to simplify all of this kind of sign expression that lies under the cube root sign, because we just want one object under the cube root to solve the integral. And this is nasty, and we want to solve it, simplifying something first. And we're going to just write sine of 3x in terms of sine and cosine. And we're going to do it in the following way. So first, keep in mind that sine of 3x can be written equally as sine of x plus 2x. I'm just writing the angle of 3x as a sum of two individual pieces, in this case x and 2x, because this way we can just split the sine into sines and cosines. So I'm going to use the following identities, that if we have a sine of an angle alpha plus another angle beta, this can be written as the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. This is an identity. We won't prove it today, but we're going to use it. And in this case, alpha is x and beta is 2x. So we can apply this formula to our formula here. I'm writing it right here. Is there enough space? Let's see. So we have sine of x times cosine of 2x plus cosine of x times sine of 2x. And okay, now I'm using all the whiteboard because here it's not easy to see what's happening if we write it in this way. But we can still simplify further, because we still have a 2x here and a 2x inside of the sine function. We don't want that. We just want x's inside the as an argument for the various sine and cosine functions. So we can still simplify further. We can apply this formula twice. And notice that if the two angles are equal, because here we have 2x is x plus x, this becomes sine of x, cosine of x, cosine of x, sine of x. And we can write it as a sum of the two, because these two will be equal in this case. And write them as 2 times sine times cosine, and of course sine of x and cosine of x. So this is something we're doing. And we can also do it for the cosine of 2x. The cosine of 2x equals to the cosine squared of x minus the sine squared of x. So we're also using this identity here. So let's go ahead and do the following. Sine of x. Don't forget to multiply it by cosine of 2x. So cosine squared of x minus sine squared of x. Then we have to add this term plus cosine of x sine of 2x. So cosine of x and sine of 2x, we said it equals to sine of x cosine of x. And it's simple, nothing too crazy. And now it's time to rearrange our equation. So we can multiply these terms, and we're doing it in the now, basically. So the first term is sine of x cosine squared of x. So sine of x cosine squared of x. Then we have to put a minus sign, and we have a sine cubed of x. This is sine to the third power, basically. And next we have all this term. So plus 2 sine of x cosine squared of x. Now, these two terms are equal, so we can just add them, and we get 3 sine of x. And notice also that cosine of x can be rewritten in terms of sine, because cosine squared of x is 1 minus sine squared of x, because the sum of cosine squared and sine squared is 1. So we can just write it in terms of sine of x, 1 minus sine squared of x. And then we have this term here, so minus sine cubed of x. Now, all of this expression here has to go in here, because it is this term here. Sine of 3x equals to all of these. And we can also distribute it, but we're doing it now. Now, without rewriting the integral, I'm just focusing on the inside right now. So we have 3 sine of x. So I'm writing it here. Well, I think there is enough space. 3 sine of x is the first term minus all of this. And don't forget the minus sign. So minus 3 sine x times 1. So it remains the same. Minus sine squared of x times 3 sine of x. So minus 3 sine squared times sine is sine to the third power x minus sine cubed of x to the third power. Now, these two terms are equal and opposite, and we can just erase them, because they both cancel out, and we remain with this expression here. Actually, I forgot to change a sign, because here it is minus, and here we have the minus sign. So I have to replace this with a plus, and also this with a plus, because it's a minus sine of 3x, so we have to change the sign to each term in this expression here. And this is what we have under the square root. We're left with 3 sine cubed of x plus sine cubed of x. And we can just add these two terms because they have sine cubed of x in common. So it is 4 times sine cubed of x. Now, this is very, very nice because we have a cube root and something to the third power underneath it. So we can simplify a lot of things. So now I'm getting back to the integral. So we have the integral of the cube root. We have 4 times sine cubed of x dx. Now, sine cubed and the cube root cancel, and we remain with sine. And this is just a constant multiple, so we can bring it outside the integral sign, and I'm writing it here. So we have the cube root of 4, just a multiple constant, times the integral of sine of x dx. And now, the final step, we can just do this integral here, and we know that the answer is minus cosine of x. So at the end of the day, we're left with minus, just put the minus in front, the cube root of 4 times the cosine of x. And don't forget the plus c, because this is an indefinite integral. And this is the answer to this question. So it was a lot of trigonometry rather than pure calculus, but at the end of the day, we got to the answer, so we're happy. And see you in the next video, and don't forget to subscribe to my channel to help me make content. so we're all happy, and you'll be notified whenever I upload a video. So feel free to subscribe to my channel, and see you in the next video.